Dear students, today we will do fast Fourier transform. We will do fast Fourier transform. Fast Fourier transform is the method to perform DFT. This is the efficient method to perform DFT. Fast Fourier transform was developed in 1965 by Cooley and Tukey. ठीक है, it's a very efficient method to perform DFT. This method perform DFT efficiently. FFT method that we will do is radix to FFT method. We will do radix to FFT method. Radix to FFT means the base is 2, mean n is equals to 2 raised to power v, where n is 2 is radix 2 because base is 2. Base will be 2. Where v is number of stages. V is number of stages and n is endpoint DFT. N is endpoint DFT. Means you can perform in radix to FFT method 2 raised to power 0 means 1 point DFT, 2 raised to power 1 means 2 point DFT, 4 point DFT. You can perform 2 point, 4 point, 8 point and 16 point DFT using this method. 8 point DFT we can perform using radix to FFT method. Two types of FFT method are first is decimation in time, also known as DIT, and the second method is decimation in frequency, known as DIF. So we will perform 4 point DFT. To perform DFT using FFT method, first bit reverse the sequence. Bit reverse means suppose you have to perform 4 point DFT, then write binary up to 3 starting from 0 and then bit reverse their sequence. Means first write 0 0 0 1 1 0 1 1. This is binary for 4 point sequence starting from 0. First write 0, decimal digit 0, then decimal digit 1, then decimal digit 2, then decimal digit 3, means from 0 to 3. Then bit reverse their sequence, means sequence is 0 0, it will be 0 0. In second the sequence is 0 1, bit reverse will be 1 0. In third the sequence is 1 0, bit reverse will be 0 1. And in fourth the sequence is 1 1, it will be write as 1 1. Now the new sequence becomes 0, this is for 2, this is for 1, and this is for 3. The sequence becomes 0 2 1 3. Now let's start from here, 0 1 2 3. So draw 4 lines, 1 2 3 and 4, because we have to perform 4-point DFT. And write here x of, write here x of 0 binary sequence, then x of 2, this is bit reverse of binary sequence, then x of 1, then x of 3. Not in sequence order but in binary reverse order. In this, the order is 0 2 1 and 3, 0 2 1 and 3. So we started from here. First we write 0, then we write 2, then we write 1 0, then we write 2, first we write 0, then we write 2, then we write 1, and then we write 3. This is bit reverse of which sequence? This binary sequence. Bit reverse of binary sequence 0 0 0 1 1 0 and 1 3. So we write here 0 2 1 and 3. Now imagine this is 2 point, 1 point and then 2 point, 1 point and then 2 point. This is odd even part and this is odd part. Then you have to perform summation of this versus this and this versus this. These are the 2 points. First consider 2 point and then next 2 points. This versus this and this versus this. Clear? Here is the summation sign. Here is summation. Here is summation. Here is summation, and this is the last summation. Clear? These are the 4 points. Now consider this as even. Now consider this as even, this is odd, this is even, this is odd. Now for the odd sequence, multiply odd sequence with -1. Remember after this point, multiply this with -1. Means first you will add x of 0 with x of 2 at this point, then x of 0 with multiplication of -1 at this point, similarly x of 1 and x of 3 Simple addition at this point. X of 1, x of 3 multiplied by minus 1 at this point. This is the completion of first stage. First stage. ठीक है, I write n is equals to 2 raised to power v. When n is equals to 4, we are performing for 4-point DFT. N is equals to 4, v is equals to 2, means there will be 2 stages. So this is the completion of first stage. Now let's start with second stage. Output from this goes to second stage. Again 4 points. 4 points. Then again in this we will consider, in this case we consider 1 even, 1 odd, 1 even, 1 odd. In this case we will consider 2 even, 2 odd. 2 even points, 2 odd points. First odd point will be added with first even point. Second odd point, second even point. Similarly, first even will be added with first odd and second even will be added with second odd. Again, the point to remember is with odd we have to multiply minus. With odd we have to multiply minus 1. With odd we have to multiply minus 1, but after this point. Clear? But after this point. Again, summation. 4 summations will be there. Summation. Summation. And summation. Clear? This is the end point. Means this is your second stage. The output of DFT is in term of capital X of K. Clear? So we write here X of 0 in sequence, not in bit reverse. X of 1, X of 2 and X of 3. The output will be in this sequence 0, 1, 2 and 3. The other point you have to remember is multiply starting from the last stage, means this is the last stage and this is the second stage. Only 2 stages will be there in 4-point DFT. So starting from the last stage there are 2 even odd points. So first odd point will be multiply with W0 4 and second will be multiply with W1 4, means in if there are more than 2 odd points then it will be 0, 1, 2, 3. 4 basically according to point of DFT. 0, 1 is the serial order. Now in this stage only 1 is odd. So from here you will write here only W0 4 and here is 1 odd and you write here W0 4. This is the butterfly diagram of 4-point DFT. Using 4-point DFT, using DIT algorithm. This is DIT algorithm, not DIF. Decimation in time. DIT algorithm. This is DIT algorithm. Now let's take example as x of n given is 0, 1, 2, 3. 0, 1, 2, and 3. Now you have to perform the DFT of this x of n sequence using DIT algorithm. Using FFT DIT algorithm. Decimation in time. This is DIT algorithm. And the sequence x of n given is 0, 1, 2, 3. This is basically the graph of this algorithm. First, you should know the value of W04. You should know the value of W04. The W04 is equals to 1. You know this. And W14 is equals to minus J, because you have to put these two values in the algorithm or in the diagram. So where you write W04, basically it is, where you write this, basically it is W04 was written here. Let's complete this diagram again. Sorry. Okay, W04 was written here. So you will write here 1 before this point. Remember, minus 1 after this point, but W04 before this point. Similarly, W14 value is minus J before this point. Means this value should be multiplied with minus J, then it will be added with this. Similarly, here we was written W04, the value is 1, and here we write W04, the value is 1. Now let's start with this example. We write here 3. Now let's start with example x of 0. X of 0. X of 0 is 0. So write here 0. Then x of 2. X of 2 is 2. So I write here 2. Then x of 1. X of 1 is 1. So I write here 1. X of 3. X of 3 is 3. So I write here 3. Now this 0 will be added with 2 multiplied by value of middle factor W04. 2 value is 1. 2 multiplied by 1 is 2. Then it will be 0 plus 2. Means here the value will be 0 plus 2 means 2. First stage, first value is 2. Then go to this stage. Here 0 as such. This 2 multiply by middle factor value 1 means 2. Then multiply with minus 1, it goes to minus 2. We add here 0 with minus 2. 0 plus minus 2 means minus 2. The value of this will be, at here the value is 2, at here the value is minus 2. Now this goes to third value. This is 1 multiply by 3. Middle factor value is 1 means 3. 1 plus 3 means 4. 1 plus 3 means 4. Means output from the first stage at this point will be 4. This value is 4. Then go to this summation. What is the value here? 1 as such. 3 multiplied by 1, middle factor value 3 multiplied by minus 1 means it is minus 3. So here it will be 1 minus 3 means minus 2, minus 2. So fourth value comes to be minus 2. This is the output of first stage. First stage output is 2, minus 2, 4, minus 2. So now go to second stage. At second stage, the here value is 2, the here value is 4. You have to add this 4 with this 2, means value goes to be 6. Clear? This 4 is multiplied by 1, total factor value remain the same 4. Now go to this value. Here the value is minus 2, this value, then this value should be added with this. Here the value is minus 2 multiplied by minus j, means plus 2j with minus 2. Minus 2 plus 2j. Clear? Now goes to this. Here the value is 4 and this 4 is added with this 4 multiplied by minus 1. 4 first multiply with total factor value 1, then it is multiplied by minus 1. Here it is minus 4 and upward value is 2. Minus 4 plus 2 is minus 4 plus 2 is minus 2. This value comes to be minus 2. Similarly, at this point, the value is minus 2 multiplied by this minus j, means 2j, multiplied by minus 1 is minus 2j, and the upward value comes minus 2, this minus 2 value. So it will be minus 2 minus 2j. This is the answer. Means the DFT of 0, 1, 2, 3 is x of 0 is 6, x of 1 is minus 2 plus 2j, and x of 2 is minus 2, and x of 3 is minus 2 minus 2j. The answer is x of k is equals to 6, comma minus 2 plus 2j minus 2 and minus 2 minus 2j minus 2j. Verify this answer with twiddle factor also. The answer will be same. Okay, thank you.